This is a Midea mini-split air conditioner circuit board that I received for repair. Due to overvoltage, it has burst. The PTC sensor is completely detached, and the traces on the circuit board have also been disconnected. The fuse is blown, and the line filter is entirely burnt. The ZNR, which is covered and packed, is also burnt. Several components on this board are damaged. First, we will replace all these damaged components and repair the traces. The backside traces are also severely damaged. This specific trace here is completely burnt. I will repair it and show you the work that will be done on this board. My approach is that I always start by conducting a physical inspection of the circuit board first. I have already identified and shown you all the physically damaged components. Now, I will remove all the faulty parts from the circuit board. I'll start by removing the ZNR. I'll check the resistor to see its condition. It's showing 2 mega ohms, which is perfectly fine. I have removed the line filter. It has melted. Next, I will remove the fuse. This is the burned fuse that has been removed. Now I'll proceed to repair the traces. This trace is connected to the PTC sensor. I will insert a wire into this section. This is the PTC sensor, and we'll install it now. The trace from the line filter to this point is damaged. Let's fix this print as well. We'll replace the line filter as well. Here's the old one, and we'll install a new one in its place. The disconnected wire has also been reconnected. Now, we will proceed to install the line filter. I will straighten this wire as its connection point is positioned on this side. Next, we will install the fuse. The fuse is now in place. The ZNR is left to install, and we already have a replacement for it. Here is the ZNR, which we will also install. Now I've replaced 4 components on this circuit board: the PTC sensor, fuse, line filter, and ZNR. When inspecting the capacitor, there doesn't seem to be any visible physical damage. Now we'll use a multimeter to check the board for any remaining issues. First, we will check the rectifier. I have set the multimeter to diode mode. Placing one probe on a pin will systematically check all the points. Then, we'll switch the position of the red probe to check for a forward voltage drop across the diodes in the rectifier. A reading of 0.528 volts is showing on the multimeter, indicating the forward voltage drop. All the diodes should exhibit the same voltage drop. If there is any discrepancy in the voltage drop across the diodes, the rectifier will be considered faulty and will need to be replaced. In reverse bias, the rectifier didn't show any voltage drop, but in forward bias it did, which confirms that the rectifier is functioning correctly. This is the best method to check a rectifier. Now, let's test the switching IC. I'll place the black probe on one of its pins. The multimeter is showing a voltage drop. There should be no zero voltage drop unless the pins are internally common with one another. If a specific pin only shows 0 voltage drop without being internally connected to another pin, it could indicate a fault. On the right side of the IC, the pins are the source, and on the other side, there are common and drain pins. When I place the probes on the source pins, the reading should show 0 because all these points are common. Next, I'll test the diodes. There should not be a 0 reading in reverse bias. In forward bias, the reading is fine, so the diode is working correctly. Now, I'll test the other diode. This one is also fine, meaning the circuit board is functioning correctly up to this point. Next, I'll power the board through a series board to check its operation. I've connected it to the series board, and now I will power the board. However, the power did not turn on, indicating there's still another fault on the board. In the next video, I'll discuss the remaining issues and how to resolve them. Stay tuned. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.